Hello class, this is Mr. Steigerwald. I'm going to go over the answers to our review for the SLO, that is our midterm final. Number 3 on the first page, we're going to mark the angles and sides of each pair of triangles to indicate that they are congruent. Remember what we talked about order matters. We know that angle V is going to correspond with angle L because they're both in the same position. So go ahead and put a 1 arc mark at each triangle regarding those corresponding angles. Same thing with U and J, and angle T and angle K. They're in the same position. For the sides, if we look at segment VU, we know it's going to correspond with segment LJ. They are in the same order, the first and second position. Okay, so you put a tick mark there. And when you match up with the segment UT and segment JK, put 2 tick marks there, and then segment VT and segment LK, put 3 segments there. Now on the second side, we're doing a proof, and it's to fill in the blanks. We're given that 2 segments are perpendicular to each other. So we write that as number 1. Now, we know that perpendicular segments form right angles. That's right from the definition. So you're going to write that down for number 2. An angle 1 and an angle 2 are right angles. Again, it's right from the definition of perpendicular segments. Now, since we have our right angles, make sure you mark it on your diagram, we know that all right angles are congruent. So for number 3, we're going to write that down, that angle 1 and angle 2 are congruent to each other by the right angles congruency theorem. And then for number 4, we're going to go ahead and write the other given statement that segment JL is congruent to segment KL. That was given to us. We mark our diagram, and then we go ahead and look at our diagram. We see that these 2 triangles have a common side. The reflexive property. So for number 5, we know that segment ML is congruent to segment ML. Again, that's from the reflexive property of congruency. We look at a diagram and we say, we know that these 2 triangles are congruent. That is, triangle JML is congruent to triangle KML by the shortcut hypotenuse leg by HL. We're done with this side. All right, on side 5, letter C. When we're doing these angle puzzles here, let's see what we got. I see that there's 120 degrees on the right hand part of this puzzle. I know I have a linear pair, so I'm going to take 120, subtract that from 180, so this angle right here has to be 60 degrees. I know that angle 2 is vertical from the 90-degree angle, so I know that's going to be 90 degrees. We have a linear pair with the given right angle and number 3, so that's going to be a right angle. And we know, again, with the right angle on 4, that this is going to be a right angle because we take 90 degrees, subtract that from 180, that'll give us 90 degrees. Now the next part, what I'll go to is number 1, angle number 1. In this triangle to the lower right, we know that there's 180 degrees in the triangle. We're going to subtract 90 and 60 from 180, and we know that this is going to be 30 degrees for angle 1. I also see I have an arc mark here by the 60 degrees. So there's another arc mark over here. So I know that they are congruent. So I know that this will also be 60 degrees. With the upper left-hand triangle, I know there's 180 degrees in a triangle. So I'm going to subtract 90 and 60 from 180. So I know that the measure of angle 7 is going to be 30 degrees. Now, the trick might be this. We're going to try to find angle 5 and angle 6. But look, we have a tick mark here, and we have a tick mark here. So we know that the corresponding angles are going to be congruent. In this big triangle here, I'll outline it in red. In this big triangle here. So I know that the measure of angle 5 is going to be 30 degrees. So when I calculate the measure of angle 6, it's going to be 180 minus 90 minus 30, which will end up giving us 60 degrees. Okay, now we're on side number 6. We're going to do number 3. Now, whenever you see a triangle inside a triangle, redraw that. Okay? So you see that two triangles got drawn right here and also right here. Again, whenever you have a triangle inside of a triangle, redraw it. We know that with angle S and angle D, both of those are going to be 39 degrees. But you see that in both triangles, down here and down here, they both share the same angle Q from our diagram. So we know that those two angles are going to be congruent to each other. So let's go ahead and put two arc marks here. Now that we know that we have two pairs of corresponding angles congruent to each other, we know that these two triangles are congruent by angle-angle similarity. So, the first triangle that I gave you was triangle QRS. Let's see. The order is Q, R, and S. So, that is going to be similar to what? And we have to fill in the blank. We know that the Q's, angle Q's, correspond with two arc marks. R doesn't have any arc marks. C doesn't have any arc marks. So I know that's going to be the second letter. Angle S is 39 degrees, and I know angle D is 39 degrees. So I know that this is going to be the third letter in that similarity statement. So yes, the pair of triangles are similar by angle-angle similarity, and write three letters down for the angles. Don't write angle Q and angle is congruent to angle Q. Write that out separately, please. On side 8, when we're doing number 3 and 4, we're using the Pythagorean theorem of a squared plus b squared equals c squared. We're finding the missing side of each triangle, and with the part that says leave your answer in simplest radical form. So number 4, you can go ahead and make that as a decimal. Same thing with number 1 and number 2. All you're doing is substituting again into the a squared plus b squared equals c squared. It doesn't matter which one is our a and b, they're both legs. I went ahead and called this a, this b. Of course, our c is always across from the 90 degrees. It is the hypotenuse. And also remember too, when you are squaring the 2 radical 2, make sure you put parentheses around the 2 radical 2 before you square it. There's all your work. Alright, on to side number 9. For number 3, we're solving each triangle, and we're going to round to the nearest 10th. So when we're solving for, let me move this down a little bit. When we're solving for our side C, we are using the Pythagorean theorem. Remember, whenever you have two sides and you got to find the third side, you're using the Pythagorean theorem. Again, that is your a squared plus b squared equals c squared. And that c, where it's located, that is the hypotenuse. So always across from the right angle. But to solve for our angle A and our angle B, we have to use trigonometry. Remember, use use that mnemonic device to help you remember if you're using sine, cosine, or tangent. To solve for our angle B, we circle it, draw the line to show which side is opposite. So we know that this side is opposite. Our C is our hypotenuse, because it's across from the right angle. So what's left over is adjacent. And that's what 14 is going to be. So we know that we're going to use tangent, opposite over adjacent. So when we write our equation, it's going to be tangent of angle B equals opposite, which is 15, over the adjacent, which is 14. Then we're going to move this tangent to the other side of the equal sign. Remember, it's going to pay $1. So our measure of angle B is going to equal to the inverse tangent, looks like tangent to the -1, of 15 over 14. Go ahead and put that into your calculator, and your measure for angle B is going to be 47 degrees. Then we're going to erase our the stuff that we put around the diagram. Let's do angle A. We circle it, and we draw the line to the opposite side of angle A. So we know that 14 is going to be opposite. C is our hypotenuse because it is across the 90-degree angle. And 15 is our adjacent. The adjacent side is always between what we circled and the right angle. So we have opposite and adjacent again, and we're going to use tangent again for number 3. So when we write it up, it's going to be the tangent of angle A equals 14, that's the opposite, over adjacent, and that's 15. We're going to circle the tangent, and we're going to move it to the other side when we calculate our angle measures. Remember, it's going to cost $1. So we're going to have the measure of angle A equals the inverse tangent, looks like tangent to the -1, of 14 over 15. Go ahead and put that in your calculator. Remember, it's the second tangent, and then 14 divided by 15, close that parenthesis, and then hit equals. All right, now let's do number 4. Now, to solve for our measure of angle A, we can take 180 degrees, subtract 90, and subtract 57, and we're going to get 33 degrees. That's the easy part. But let's go ahead and calculate the two sides. First thing we're going to do is we're going to go ahead and circle our given angle measure of 57 degrees. We know the side across from it is going to be the opposite side. We know the side across from the 90 degrees is the hypotenuse. What's left over is the adjacent. The adjacent side is always between your 90 degrees and the angle measure that you circle. So we're trying to solve for, let's solve for our A first. So we got to find which one has the opposite and adjacent. Oh, it's tangent again. All right, so we know that the tangent of 57 degrees is going to equal opposite, which is 2, over the adjacent, which is A. We go ahead and make a proportion so we could cross multiply, and we might have to divide, but we'll see that in a moment. So A times tangent of 57 degrees is A times tangent of 57 degrees, and that will equal 1 times 2 is 2. We're trying to solve for A, so let's divide both sides by tangent of 57 degrees. These will cancel out, so we will have A equals 2 over tangent of 57 degrees. We go ahead and put that in our calculator. It says to round to the nearest tenth, so we know that the measure of angle A, we know that A is going to be 1.3. Now let's go ahead and find the measure of side C. Doing side C, we know that we're going to use the opposite and also the hypotenuse. This is going to be sine, and I wrote it down here. Cross multiply, and we're going to have C times sine of 57 degrees equals 2 times 1 is 2. Now go ahead and divide both sides by sine of 57 degrees so that you can go ahead and cross off the sine of 57 degrees, and you're going to get C equals 2 over sine of 57